Hello, welcome. Today we are here to discuss about the question called delete the middle node of a linked list. Delete the middle node of a linked list. So this question number is 2095 from lead code. It's of a medium level question. So now let's try solving this question. Let's understand the question and let's crack this out. So you're given the head of a linked list. Delete the middle node, return the head of a modified linked list. So they'll give you a linked list like this. Okay, let's draw some links here. In this way, they'll give you a linked list. Okay, now we need to delete exactly middle one and we need to return the head. We need to return the head. This is what we need to do, guys. Very simple one. So, but if obviously the question looks simple, but they give medium, which means there are some tricks that have to be figured out. So the middle node of a linked list of size n is n by 2. Okay, that's great. So if there are n elements, okay, the middle node of a linked list is n by second element, n by 2th element. Okay, from the start using zero based indexing. Okay, okay. To make it clear to everyone, they'll not give you indexes, guys. Okay, they're just assuming there is an index, but they're not going to give us an index or array. At the end, that is a linked list. So they're just giving us an example thing. So let's say now let's go through the example that will make us clear to understand this one. So in this example, the nodes are 1, 3, 4, 7, 1, 2, 6. So the head. So they're asking us to delete exactly the middle one, exactly the middle one. This should be deleted. So if you observe, total count is 7 and 7 by 2 is your 3. Basically, third index node. If you observe, if this node is basically first node, but they are assuming it as a 0th node, first node, second node, and third node. So in this way, they are deleting the third node, guys. Okay. I hope you understood this one clearly. So they are deleting the third node in such a way that it first node is started from 0th index. So in this way, they are doing this deletion. Okay. I hope this is clear. This makes some sense to everyone. So now let's see one more example. Yeah, here also even here. What is the total count here? 4. Okay, 4 by 2 is how much, guys? 4 by 2 is 2. So this is your not first node, 0th node. This is first node. This is the second node. This is the second node. Basically, they are assuming to start from 0th index, right? That's the reason. This is the second node to be deleted. To be deleted. I hope this you understood it clearly. Now let's go to the one more example which we have given by them. Here the total nodes is 2. 2 by 2 is obviously 1, which means you need to delete the first node. This is 0th node. This is your first node. So the starting node is treated as 0th node. Okay, starting node is treated as 0th node. Keep this in your mind, guys. Okay, now let's see how we can solve this question. We need to go to basically, we need to delete the middle node. That's what the main goal is. Okay, let's take this one. Let's take one example. 1, 2, 4, next 7, 9, and 10. This is pointing to null. This is pointing to null. Basically, this can be solved in two ways, guys. This can be solved in two ways, where one of the way is using count method. Count method. So this we can do using the count method. Okay. Second way is to use the slow and fast pointers. Slow and fast pointers. Slow and fast pointers, guys. These are the two ways which we can do. So let's see with the first way. Let's see with the first way, count way. So let's count. How many nodes are there here? How many nodes? 6 nodes. 6 by 2, how much? 6 by 2, how much? 6 by 2 is 3. So you need to start from here. This is your 0th node. This is your first node. This is your second node. This is your third node, which means you need to delete this. You need to delete this, which means you need to go till here. Why we need to go till here? Because I need to delete this node, which means I need to link 4 to 9. I need to link my 4 to 9, guys. I like to link 4 to 9. So if I need to link 4 to 9 like this, okay. If I need to delete 7, I need to link its previous one to its next one. Obviously, that was the thing, right? This is being deleted, which means 4 is linked to obviously 9. So if I need to delete third node, I need to stay here before that one. Okay. So this is what we need to do. You know how to find out the count, right? I hope you know how to find out the count. After finding out the count, you need to traverse from the beginning. Assume this as first node, second node, and this is your third place. Go here and simply delete this one. Simply delete this one. That's all. This is what we need to do using the count method. Using the count method. So let me write down the code for you people. Let me give you some pseudo code kind of thing for you people. Okay. First thing is count of nodes. Everyone find, we need to find out the count of nodes. After that, count by 2. Count by 2. Third thing is start from first node and go to go to uh, go to okay. So we will start from first node. Basically 0 indexed one. Okay, go to third node. Okay, go to not third node. Basically go to, okay, let's store count by 2 in, let's say m. Go to mth node, which means according to zero based indexing, it will be m minus 1 value. It will be m minus 1 node. Go to mth node. Okay, m minus 1 according to the index, m minus 1 index. Why we need to go to one step behind, guys? One step behind. Why we need to go? Because if I need to delete the current one, I need to stay at the previous one and I need to modify the links and modify the links. Modify the links, which means obviously deleting. That's mean deleting. That's all. That is the thing that we need to do. I hope you understood this one. I hope we need to count number of nodes, calculate the value of mid, start from first node, go to m minus 1th node, and you simply delete. You simply delete. Okay, guys. Okay. Let me. Okay. Now let's take one example. Let's see this. So 1, 2, 3, and 4. 4 is pointing to null. Okay. Now, first thing is counting, guys. So let's take one variable called c, which is initialized with how much? 0. This is your first node. So count will become how much? Count became 1. Next, go to next node. Okay, we have a node. So count will become 2. Go to next. This is also a node. This will become 3. Go to next. This is also a node. Count will become 4. Go to next. This is not a node. This is null, which means end. Which means end. So count is how much? Count is 4. Count is 4. What will be count by 2? M equal to 4 by 2. What is the answer? 2. 4 by 2, 2. Which means we need to delete the second node. We need to delete the second node, guys. We need to delete the second node. Okay. Obviously, if it is zero based indexing, which node it is? 0, 1, 2, and 3. If you are taking it as zero based indexing, which node we need to delete, guys? This node we need to delete. The highlighted one should be deleted. Highlighted one should be deleted. Okay. Now let's start. I need to delete second node. I know. So to delete the second node, where I need to stay at? I need to stay at this node. I need to stay at this node. Let's start from the first. This is my which node? This is my first node. This is my first node. Okay. I need to go till second node. I need to go to second node basically. M minus 1th node. According to the index, it is 1. So let's say this is my which node? Okay, let's not even go to first, guys. Let's say this is your which node? 0th node. I need to go till first node. Yes or no? According to the index, I need to go till first node. This is my 0th index. So this is not my current node. I will go to the next one. What is the index of this one? 1. This is which node? First. Okay, this is 0th node. This is the first node. I also need first node. I will stop here. I will update the link. How I will update the link? I need to delete this 3, which means whatever the 4 is there, this will be linked to 2. Yes or no? 4 should be linked to 2. 4 should be linked to 2. But in between we have 3. So 2 is linked to 3. 3 is linked to 4. Now I need to remove this 3, right? So how we will remove? 2's next. 2 dot next should be equal to 3 dot next. 3 dot next. 3 dot next. Okay, 3's next should be equal to 2's next. But where is the address of 3? It is again in 2 only. 2 dot, okay, 2 dot next dot next, which means 2's next is 3, 3's next is 4. We are getting this 4 address and linking this one like this. Okay. This is the reason, guys, we are writing dot next dot next. We are not writing it randomly. We are writing it because of the logic. Okay. I hope this approach is clear to everyone. I hope this approach is clear to everyone. So what we will do is, let's try to delete this one. Okay. Let's try this one. So this is one approach, guys. This is just count approach. I hope this is clear to everyone. Now let's go to the second approach. Second approach name is slow and fast pointers. Slow and fast pointers. What this slow and fast pointers do is, slow pointer will always go 1 step, fast pointer will always go 2 steps. Okay. What is this slow and fast do is? Slow will move 1 step forward. Fast will move 2 steps forward. 2 steps forward. So every time slow will be moving 1 step forward, fast will be moving 2 steps forward. If you observe the ratio between these two, if this goes 100, this will go exactly 50. If this goes 1000, it goes 500, which means if it reaches end, it will be in the middle. If it reaches end, it will be in the middle. That is the reason, guys. That is the reason we are doing here. We are taking slow and fast pointers because if fast reaches the end, slow will be exactly in the middle. Slow will be exactly in the middle and fast will reaches the end. Why I am saying, if you take this total length as 10 centimeters, this length will be how much? Obviously 5. Why I am saying slow moves how many times? Only 1 step. Fast moves 2 steps. So in that way, if it is moved 10, it will be exactly at 5th position. Okay. This in terms of length and all, but we need to see in terms of linked list. Let's see that one. So let's take one example. 10 to 20, 22, 30, 32, 40, and 42, 50, 52, 60, 62, null. Okay. Now let's take, this is your slow, this is your fast initially. Initially, this is your slow, this is your fast. Now, first we will move slow pointer. Slow move to 1 step. Slow, how many steps it will move? Only 1 step. What about fast? It will go 2 steps. This is your first step. This is his second step. So this is your fast now. This is your fast pointer. Okay, this is your fast pointer. Next, slow comes to this one. Fast goes to here. Fast goes to here. Fast goes to here. Next, slow come to this one. Fast goes to null. Fast goes to null. If you observe, this is the exactly middle node. This is the exactly middle node. You can count. What is the count? 6. 6 by 2. 6 by 2 is 3. So I need to remove third node. Okay. Third node is 30. No. No. We should take from 0 at end. Like 0, 1, 2, 3. So we need to delete this one. Okay. But slow is pointing to which node, guys? The node that I need to delete. But how can I delete that current node which I am pointing? If I delete this 40, which link will be updated? 30's link is updated to 50, right? But I don't have access to 30 and I have access to 50, where its next is 50. But what about the previous one? What about the back one? I don't have access. So that is the reason whenever you are moving your slow, keep one as a previous. Keep one as a previous. So whenever you are moving slow, mark this as a previous. Moving slow, mark this as a previous. Moving slow, mark this as a previous. Now you have previous nodes link also. Now simply previous dot next equal to slow dot next. That's all, guys. This is all we can do. I hope you understood this one. Or if not, let's iterate on this again. 1 to 2, 2 to 3, 3 to 4, 4 to null. So this is your, what is this one? Slow. This is your fast. Initially, P is pointing to, it will be initially pointing to nothing. Previous is nothing, no. Now I will move fast pointer to second step. Now I am moving, sorry, not to the second step, guys. Fast will move 2 steps. Fast came here. This is my fast. Now what I will do, before I move slow to the next one, I will mark P2 here. So P will be pointing to this one. P is pointing to this one. Now S move it to this one. Okay. Again, fast will move. Fast will go to null. Fast is going to null. So I need to move slow to this one. But before I move S2 here, I will move P2 here. So this will become my P and this will become my S. So I know this is the node I need to delete because I reached the end of the list. I reached the end of the list. So I know this is the node to be deleted. Okay. So if to delete this 3, what I need to do? To delete this, what I need to do? This 2 should be linked to 4. So I have address of 2 in P pointer, address of 4 in slow dot next. So P dot next will become S dot next. So this is the thing that we need to do. This is the thing that we need to do, guys. Okay. I hope you understood this one. So let's code this. Okay. First thing, list node. We need to have 3 pointers. What is the first one? Slow, fast. Where slow is pointing to head. Fast is also pointing to head and P is pointing to null. Okay. While fast not equal to null and then fast dot next is not equal to null, then I need to move slow and fast pointer. Slow equal to how many times? Slow dot next. Fast equal to fast dot next. But before you move your slow, what you need to do? Your P should be pointing to slow. You need to point P to slow. Why we are pointing? Because this will track your previous node. This will track your previous node. And at the end, P dot next will become slow dot. P dot next will become slow dot next. Slow dot next, guys. This is what we need to do. But in the constraints, what they give is they will also give some in link, empty list, and single node. So if head is equal to null or head dot next is equal to null, then what I need to do? Simply return null. Okay. If you have only empty list, you can't delete anything. Return empty. If you have only one node, you need to delete that one node because middle is 0, 1 by total 1 by 2 is 0. 0 is we need to delete the 0 next. So that's the reason we are doing this, guys. So if list is empty or having single node, return null. Null means what? Empty. Null means empty. So we are doing this one or else we are using slow and fast moving. Why we are using P? Because to track the previous node. Why we are tracking the previous node? Your slow pointer is exactly going into the middle one. We are not going to one step back. We are exactly going into the middle one. That is the reason, guys. So that's all we have to do. And then I think we missed one thing. Yeah. And then we need to return head. We need to return head. We missed that one, guys. They are asking us to return head. Okay. So this is the question. I hope you understood this one. We are returning now empty. We are returning empty if it is, we are returning empty if it is having one node or empty, or else we declare the 3 variables slow, fast, and P. We are moving, checking for the condition if fast is reaching the end, or else we are updating the P, moving slow and fast. We are updating P with slow because we need to track the previous one. And at the end, P dot next equal to slow dot next, which means previous node is linking to the next node of current node. That's all, guys. This is what the code is. I hope you understood the logic. Okay. Thank you.